Hi everyone, welcome to our last video for topic 21. In this video, we're going to talk about the Pythagorean theorem and why it's useful for area problems. So let's start off with what is the Pythagorean theorem, right? You might remember that the Pythagorean theorem is a squared plus b squared equals c squared. You might also have remembered, maybe separately, right, that it has something to do with right triangles, okay? So in a right triangle, you know, I've got a squared plus b squared equals c squared, and a, b, and c are my sides. That is the Pythagorean theorem. It is a way to predict the side lengths of a right triangle. A right triangle being one with a 90-degree angle. Now what's important is I do not get a choice on what side is C and what side is A and what side is B. C is always the side opposite of my right angle. Okay, that is what we call the hypotenuse. It's the one opposite of the 90-degree angle. And then A and B are the ones that are not opposite my 90-degree angle. They are the ones perpendicular. We call those the legs, the perpendicular sides. Now, what's powerful about the Pythagorean theorem is that it allows us to predict side lengths in a right triangle using only two side lengths. You might remember from triangle congruence that sometimes, like if I had given you A and B, you could get C, even if it wasn't a right triangle, right? You'd have side, angle, side, you know? But what if I had given you C and B? Normally that would be side angle, right? And you wouldn't be able to get A. But if it's a 90-degree angle, you can. There's only one way to get a certain side length of A if you know B and C in a right triangle. Let's discuss that, right? If you were saying, okay, I've got a, let's say, I have a 5-foot ladder leaning over, all right? 5-foot ladder leaning over against a wall, and it touches the wall 4 feet up. What is the distance away from the wall that that ladder touches the ground? It's always, I messed up here a little bit, so allow me to fix that, but it's actually always going to be 3. Let me fix that a little bit. There we go. It's always going to be 3 away. Always. There's no way to lean a ladder against a wall that's 5 feet long, touches 4 feet up, and not have it be 3 feet away. That's not necessarily intuitive or obvious, right? But the Pythagorean theorem shows it to be true. How would I know it's 3? What I would do is I would go to my Pythagorean theorem and I would plug in a squared, which I don't know, right? In this case, we didn't know it was 3, so we're going to call that x, okay? Plus b squared equals c squared. I know a is x, b is 4, and c is 5, right? So I'm going to solve for x, okay? When I do this, I get x squared plus 4 squared equals 5 squared. I can find what 4 squared and 5 squared are, and I would get x squared plus 16 equals 25. Now, I want to find x squared. So I have a hint here. X squared is whatever I need to add to 16 to get it to 25. So to find what's the difference between 16 and 25, I need to subtract 16 from both sides. I get x squared equals 9. That's what 25 minus 16 is. So what squared equals 9? You might know this off the top of your head, but if you don't, I would use the square root button on a calculator. That means take the opposite of a square, right? So that says to 9, like it says, what times itself equals 9? That's what the square root button does. And that would get me x equals 3, like we already knew, right? We knew it had to be 3. So that's one way to use the Pythagorean theorem, to find a missing side in a right triangle. And likewise, I could use it to do the reverse. I could find C if I know A and B, right? So if I had said, okay, make a right triangle such that, let me change the measurements here. And this time, notice it's not going to be to scale, right? If I said this is 5 and this is 12, what is X? So let's rewind all the way to the top and see, okay, how does it change if I'm solving for C, right? Because notice I don't get a choice on what C is. I don't get to say it's X is A or X is B here. It is C, right? So I've got 5 squared plus 12 squared equals X squared. That's going to be 25 plus 144 equals X squared. That is 169 equals X squared. Now, I don't know what that is off the top of my head. So I take the square root of 169 equals the square root of X squared. I do this because I want to get rid of the squared around X. I want my final answer to be X equals something. So every step along the way, I am doing whatever I need to get closer to x equals something. I'm playing spot the difference, right? Before, x was being added to 16, so I needed to subtract 16. I don't need to subtract anything this time because x squared is already on its own, right? There's no need to subtract 25 or to subtract 144. X squared is 25 plus 144. So adding those together will help me get closer to finding what x is, right? In this case, I would plug the square root of 169 into my calculator, and I would get 13. So x is 13. Cool. If this was in feet, remember, right? Units are important. This would also be in feet. When you use the Pythagorean theorem, you are solving for lengths, right? So it's going to be feet or yards or meters. This is not for area. This is for side lengths. So it gives you a length, feet, not squared feet, okay? Now, how do we use this for an area problem? Because if it doesn't give us area, why do we need to know this? So let's give you an example problem, okay? Here's the example of a triangle problem where I would need to do this, okay? Here's a triangle problem where I would need the Pythagorean theorem to solve it, all right? I'm saying this is 6 or whatever, right? And I'm going to give you this diagonal length right here, okay? So I'm going to give you this diagonal length here, which is 11. And I'll say these are in feet, right? Remember, this 11 diagonal length is not the height, right? 6 is the height. It's not the base because it's going this ways, right? So I need this, the base, in order to find my area of this triangle, right? So if I said find the area, what would you do? Well, I could try to count it, but there's no guarantee that this is actually what it looks like, right? So I need to double check. I would use the Pythagorean theorem, right? I would say 6 squared plus b squared equals 11 squared, right? So I would get 36 plus b squared equals 11 squared. And that's going to be, what's 11 squared? 121. Now, to solve for b, I need to subtract 36 from both sides, see, to get b on its own, right? So I've got b squared equals 115 minus 30, so that's 85. And now I need to find the square root of b squared and the square root of 85. That means b is going to be whatever the square root of 85 is. And notice the square root of 85, if you do it on a calculator, because again, I don't know that, is 9.29. So it's very close to 9, which it looks like in the picture, but it's a little past that, right? Remember, pictures are not necessarily to scale. So my final answer would be 9.29 feet. Now, that's not the final answer for this problem, right? Because all I did was find the base. To find the area, I need to do 9.29 times 6. The entire reason we did this is because when I said, okay, base times height divided by 2, right? I know the height, I don't know the base. So I needed to go back and see, okay, what can I do to find my base? We just found it, it's 9.29. So now I do 9.29 times 6, and I'm gonna get 55.3. I'm going to divide it by 2 because it's a triangle. And I get my final answer is 27.65 square feet, right? So what's tricky about this problem is that you need to use the Pythagorean theorem. I did not give you the base. I gave you a measurement to get you to the base, but when you see a right triangle and you go, I'm not being given all the 3 sides I needed, I'm being given some random side I don't, to get that third side, you use the Pythagorean theorem. I won't go through this as an example, but here's some other problems where you would need to use the Pythagorean theorem, right? If I gave you a trapezoid that looked like this, and I said, okay, this top base right here is 7, this bottom base right here is 13, and this diagonal length right here, right, that is 4. And this one over here is 3. What is the area of this? Well, you don't care about these diagonal things, right? That's useless. What you want is the height. And I did not give you the height. But I did give you a means to find it with 2 right triangles, right? So I could use either of those right triangles in order to get there, okay? That's a really hard one, though. What if I gave you an easier one, say a trapezoid, right? That was a right trapezoid. And again, I did not give you the height. I said this is 5, This is 9, let's say. Again, just giving you random 5.5, 9.5, whatever. Like it doesn't have to be the scale to the grid I am drawing it on, right? And then I don't give you the height, but I do give you that this is 4, right? If you know that, I could find this height by using a right triangle and figuring out what this distance is. It's a tricky problem, right? But you'll notice anytime I'm giving you not the height or not the base, but one of those two things, you can use the Pythagorean theorem. I could even get kind of wacky with it, right? I could do something like, here's a rectangle, and I've got the height, which is 9, right? And I'm going to give you that diagonal across the rectangle, which is, you know, 15, right? But I don't give you the base. And that's what you need to find the area of a rectangle, right? I've given you the diagonal of it, I've given you the height of it, but I didn't give you the base. So if you want to find the area of it, good luck. You need to find that base, and you need to use the Pythagorean theorem to do so. Okay? So the Pythagorean theorem, hopefully that helps you understand it. Once you got it down, it's really one of two processes, either the one where you're solving for C or the one where you're solving for A or B. Look for triangles that are right triangles where you need a third side and you're given the other two. Anytime that happens, you're using the Pythagorean theorem, okay, whether it's in an area problem or it's on its own. And then using the Pythagorean theorem is just plugging into the formula, using the algebra that you have to use to get this side you're solving for on its own, and you might need to use a square root along the way. So good luck. Hopefully that helps.